Better to be frustrated than bored. The incidence, persistence, and impact of learners' cognitive affective states during interactions with 3 different computer-based learning environments. Well, that is a mouthful. I simplified it to be just frustrated and bored. But this paper really investigated the cognitive affective states that happen when working with different learning environments, the persistence of those states, and how much these states correlate with poor learning. Well, kind of like what the title says. These ideas were studied using different populations, both from the Philippines and the US, with different methods, both self-reporting and then the field observations, and using 3 different learning platforms. And the goal really was to look for more generalizability, but as a consequence of that goal, there was reduced ability to draw conclusions between the differences of the different systems that they were looking at. So a quick agenda, I'll go over some history, the affect states that they were looking at, the system, talk about some discussion points, and then some questions. We eventually hope to create affect-sensitive learning environments that respond constructively and effectively to boredom and confusion. When we do, we will have made significant progress towards improving students' learning experiences. I think that was kind of a good quote to shape why they're pursuing this. So the 3 research questions that were posed: 1, what cognitive affective states do students experience more often during learning sessions with computerized learning environments? 2, are there differences in how these states persist over time? That is, are there some states persistent and others ephemeral? And then 3, what is the impact of cognitive affective states on students' choices of how to interact with an interactive learning environment? So just to give you some history, back in 1997, Picard wrote a book called Affective Computing, which was pretty influential. And then since that time, there's been a lot of research focused on developing different technologies that respond to these affective states. In an attempt to develop these more effective user-friendly applications and platforms, a lot of researchers attempted to use these affective states into the interface decision cycle. And kind of the why is that there's this complex interplay between cognition and emotion. With that complex relationship, some key user states that are highly relevant to students' experiences, such as confusion and engaged concentration, can be considered a blend of affect and cognition. And that's a quote. They focused to some degree on ITSs, or intelligent tutoring systems, and they're particularly good candidates for this type of improvement by addressing connections between affect, cognition, motivation, and learning. And they're particularly good for a couple different reasons, but really they say that they promote active learning, and with about 1 standard deviation improvement, which they said in the papers about 1 letter grade compared to the control. And I think it's been referenced before in prior papers, I think last week and weeks prior, that an inexperienced human tutor is worth about 0.4 of 1 standard deviation, but an expert human tutor is worth about 2 standard deviations. Much of the affect research has focused on, it was Ekman's 6 basic emotions. They're hypothesized to be, everywhere and ubiquitous in everyday experiences. And the 6 of them are fear, anger, happiness, sadness, disgust, and surprise. But Baker in this paper, he's really saying, well, these aren't the most relevant in the learning process. So as an alternative, they came up with, he focused on cognitive affective states that are really more in line with cognition and deep learning. And so a little bit more history. Back in 2001, Court, Riley, and Picard created this 4-quadrant model that explicitly links learning and affect states. Then to continue that work in 2003, Russell made what they call a core affect framework, which you see in this diagram here. And then Baker then mapped the affect states onto this quadrant. These are all different affective states. So there have been multiple studies trying to detect affect in learning environments, but there's really little understanding on the impact of affect on students' behavior and learning during tutorial sessions. These states, as you see this thing, are pretty straightforward. Everyone can understand. BO is boredom, frustration, delight, surprise. This one's neutral. That's really the 7th state, which we'll talk about. But then the one that EC, which is engaged concentration. This is similar to flow. Additionally, some research has focused on reducing frustration, and it's really not clear frustration is always negative, which I thought was kind of a surprise. I think that the valence of that would be negative, but a 2004 study by Guy has proposed that frustration to a certain degree actually may enhance what they call enjoyability of computer games. I thought that was interesting. And it's not known how harmful or persistent the affect states currently are for negative affect states. So for example, confusion, that's a cognitive affect state that is often perceived as negative, but has really been shown to be positively correlated with learning. So I thought that was interesting as well. So Baker's thought is that some of these cognitive affective states may be quite persistent, meaning that they linger. Because of this, the learning environment should be able to respond, especially when the states have negative valence. They also point out that there's other states may be brief. They call it transitory. A response from the learning platform and environment really may not even be needed. So as an example, flow, which they say is similar to that engaged concentration from the previous slide, they say that's quite persistent, that hangs around. But it's not clear whether either flow or engaged concentration is more persistent than other states like boredom. And of course, there's one, they say surprise, which is very commonsensical. It's very short-lived. Engaged concentration, boredom, confusion, and frustration are more persistent than surprise. And then also in the paper, they brought up gaming the system, which they showed to be associated with poor learning. And our friend Neil Heffernan showed that the same students who game the system also experience frustration. So Baker then posits that frustration leads a student to game the system. Baker previously showed in another paper that user interface features that are designed to increase interest also decrease gaming. So it's possible that boredom actually lead students to game the system. So a few of the challenges that they identified when they're conducting these studies. One is that they want affective computing to be generalizable. That's difficult to do, and partly because of just the diversity of potential users. And then they gave some examples, like it's difficult for people to recognize different emotions from different cultures. And it's easier to recognize certain emotions from people in the same culture. And then they talk about age and gender and personality as different factors. For age, they said like younger children generally are more expressive than teens and adults, and that they're less likely to suppress and disguise their emotions like maybe teens and adults would. And also they talked about gender, like boys and girls often show different patterns of engagement to the same classroom activity. And boys and girls who are disengaged with learning software may require different responses by the system. So here they say that there's several ways that affect could be measured in these systems. And they talk about automatic detection of cognitive affective states, real-time affect detection, acoustic prosodic cues, lexical features, physiological features. But then in the end, they said all these are generally expensive. You got to have like chair monitors or eye tracking software and all this stuff. And they said, just humans are the way to go. And they chose in their studies just to use humans. Just a quick summary of some of the platforms. AutoTutor is fully automated computer tutor. It attempts to have human conversations, tries to hold conversations with students basically in natural language. Another platform is called, short for TIM, The Incredible Machine. And this is just a platform where kids are actually asked to go through different logic puzzles, and they're basically Rube Goldberg machines or puzzles. And they can, just like in the last one, they can ask for hints when they get stuck and things like that. It's A+6. This is a math platform, tutoring platform, intelligent tutoring platform. All three environments were studied using human judgments, like we said, and it was about the 6 affective states. And it's really 7 because there was the neutral that was included as a 7th affective state. So like we said before, they dealt with different populations, different methods, and it's all summarized in this table. Different number of participants, different age ranges. I thought this was notable that there was only 5 males versus 23 females in that study. And you could see the different AutoTutor, Incredible Machine, and then A+6. And then this one was self-reports versus the other one where we had observers collecting the information. So various methods, but what was interesting, despite all the different methods, there really were some similarities in the profiles of the cognitive affective states. So here's some results. They conducted 3 ANOVAs, 1 for each platform, and they found that all of the ANOVAs were statistically significant. They also did a Bonferroni post hoc test, and I'm familiar with Bonferroni, but not the math behind it. But the results are in this table. You can see here, these are all the effective states. This is AutoTutor, this is the Incredible Machine, and this is A+6. The standard errors are here. But what's interesting here, these are the proportion of each cognitive affective state observed in the learning environment. So just a quick interpretation. For the AutoTutor, surprise happened about the same as delight. And boredom, confusion, engage, concentration, frustration, and the neutral affective state all were about equal and more than the other two. And simply, users are less likely to experience delight and surprise than the other states. Notice for the Incredible Machine, surprise was on par with boredom, delight, frustration, and the neutral, but less than engage, concentration, and confusion. So long and short, you could see engage, concentration dominates when learners interact with this game-like system. So here, you could see engage, concentration just blew all the other ones out of the water. And then a distant second is confusion. And then A+6, same sort of thing, engage, concentration was the big winner. And confusion followed up, looks like, as number 2. One other point that I wanted to bring up was if you look at boredom and you compare that to frustration, boredom and frustration in all of these, you see that they're very, very similar, right? So just hang on to that because that'll be interesting as part of the conclusion. But they're about the same here. Another result, they asked the question again, do different states have different overall degrees of persistence? And what they did is they came up with this metric L, and this is right here is the name of it, or not the name, but kind of the formula that they use to calculate this metric. And it's the likelihood of a transition when using the various platforms. And so the graph shows, I put a bunch of arrows next to the ones that are statistically insignificant, but the graph shows that boredom is really the most persistent state. And they called it's verging on a mood. So the probability that a bored learner will stay bored is significant in all 3 platforms is much higher than the average for the other states. Surprise, on the other hand, is on the other end of the spectrum, and they say that really doesn't even persist at all. So here you have boredom, and you can see these are for all the different platforms, and then here is surprise. So one is statistically insignificant, the other one's negative, the other one's barely showing up. So they say this does not persist. That's kind of commonsensical, like we were talking about, but boredom, when you're talking about these transitions, the chances of it following up as an affective state after some sort of transition, this is the one that the kids will most likely experience, which is a notable finding. Then they used another formula to determine whether any cognitive affective state is associated with increased gaming behavior. So here you can see this is the method they used to determine that. And this graph shows that boredom really is the only state that leads to gaming the behavior. So here, the gray, or not filled in symbols show that it's statistically insignificant. So you have only one data point that shows that boredom is really the only state that leads to gaming the system. And so boredom, in the end, may reduce learning more than other cognitive states. And it's by getting students to kind of engage in this gaming of the system, which prior we talked about is associated with poor learning. What do? We know if frustration is a natural part of cognitive processing activity, it may not require external intervention. So in the paper, it touched upon that frustration, while it may have a negative valence, it may not persist, and it could be, there's positive benefits in terms of learning. So there may not be any sort of remediation necessary there. On the other hand, Results suggest that boredom should receive really more attention than frustration. That in many cases, frustration may not be remediated, like I just said. In the end, a couple questions that I came up with. Did some research on Fry back in 2001, claimed that boredom is beneficial to kids in moderation. So I was trying to be a little contrarian here and find something. And there is stuff out there that shows that boredom is beneficial. So do we actually think that's true? And when do you think it's beneficial? When do you think boredom is beneficial? And then if both of those, if you can get to that, and so should we work to remove boredom entirely from these platforms? So hopefully that spurs on some conversation. Sorry that I couldn't be there tonight.